Okay, E1 reflection solution. So you've just learned about sampling methods and you're entering the least mathy unit of the year. So it's all about vocab. To conduct an opinion poll on virtual learning, 10 classes were randomly chosen at Cedar Ridge, and all students in each class were polled. So it's important to know what was randomly selected. Was it individual students or was it classes, groups of students? So this one is called a cluster sample because we're taking group names, which are the 10 classes. We're throwing them into the hat, mixing it up, and randomly picking the groups, and then you include everyone in the selected group. We are including everyone in the selected classes. This is a cluster sample. Number 2, to maintain quality control in a brewery, every 20th bottle of beer coming off the production line was opened and tested. So this is called systematic sampling. What you really do is you randomly pick a starting point, but then you go the same number of people or whatever it is down the line, and you pick that individual. So in this case, we're doing every 20th individual, and this is systematic sampling. Cedar Ridge surveys all students during registration for classes to determine their opinions on AP. There is no sampling per se going on here. We are just talking to everyone, and that is called a census. To judge the appeal of a proposed television sitcom, a random sample of 10 people from each of 3 different age categories were selected, and those chosen were asked to rate a pilot show. So what we're doing, this is one of the times where you're actually going to have 3 different groups, but you're doing like 3 different samples. So stratified random sampling, in this case, we're taking 3 samples. One from the first age group, one from the second age group, and one from the third age group. Oops, escape. Oh, I didn't even see that. All right, so pointer options. And let me see if I can update the settings. There we go. That's funny. Okay, so this is stratified random sampling because you have a hat for one age group, a hat for another age group, and a hat for another age group. Okay, so stratified random sample. To conduct a study on depression among the elderly, they interviewed the first 30 residents they saw at a nursing home. So first of all, you don't even, they just looked at the first set of residents. They didn't try to make any effort or randomization here. This is lazy sampling, also known officially as convenience sampling. I personally think they should call it lazy sampling, but that's fine. Subscribers to a YouTube channel were given unique number IDs. Then a sample of 30 subscribers was selected by using a random number table. The subscribers in the sample were invited to rate different music streaming services. So this is where we're putting all the individuals in one hat, and we're just randomly picking from them. Now, in this case, we numbered them, and we're using a random number table, not literally a hat. But anytime you see where they have a random number table and they just have the list of the people they're choosing from, which is the subscribers, then that is called a simple random sample. Number 7, what type of bias could result in this situation? In a survey, students were asked if they cheated on their last quiz, statistics quiz. And so if I do this is the one I made this one. Before I grade your test, please complete this survey on my teacher performance. Most people are going to give a thumbs up, or if I ask you in class if you cheated, very few will stand up even if they did, because it's like there's not an upside generally to standing up and saying, yes, I cheated on my quiz, because there could be consequences from me. There could be judgment from the classmates, so you feel this peer pressure to answer in a certain way. So we call this response bias. It's not non-response. It's actually a response. So if I said, raise your hands if you did not cheat on your last statistics quiz, you will feel forced to raise your hand so that I see and your classmates see, okay, they didn't cheat. So I'm forcing a certain response. What type of bias could result in this situation? In a survey, students participating in a Zoom conference are asked if they have good access to Wi-Fi. Well, let's go ahead and go over the sample frame. So the sample frame is the group that I'm choosing from, right? So what kind of people am I choosing from? People in a Zoom conference. Odds are they have good Wi-Fi. Who am I leaving out? Maybe the people with bad Wi-Fi that couldn't join the Zoom conference, so that would be under coverage bias. What type a customer at a restaurant chooses to fill out one of the comment cards at the table and turn it in. This is actually a very common form of surveying, and it's voluntary response bias, because there are two types of people that are going to take the time to fill out a comment card and leave it. Because most of us, we don't fill out every comment card we see. So if we're like, it was okay, we're not going to fill out a comment card because it's not worth our time to leave a comment. So the only two types of people that would go through the effort of filling out a comment card are those that are very happy with the service and they want to make sure that their server or whatever it is gets kudos, or those who are very upset with their service. And so this is called voluntary response bias. It tends to lead to extremes. This is also an issue with Amazon and their ratings of products, because you tend to have people who really love it and people who really hate it respond. What type of bias could result in this situation? They're sent an email survey about their college plans. Odds are you're going to say, delete, throw away. So non-response happens when you do get the survey or whatever it is, but then you make the choice, you the individual make the choice not to do it. Under coverage is when we are able to get the survey to the individual and they don't even have the option to say no. So non-response bias is when you have the option to say no, and it's pretty frequent. You want to know the opinions of American school teachers about establishing a national test for high school graduation. You obtain a list of the members of the National Education Association, the largest teachers union, and mail a questionnaire to 2,500 teachers chosen at random from the list. By the deadline, 1,347 teachers returned the questionnaire. The population is. So the population has to do with a sample frame. The population, if you're properly covering your population, right? So in this case, our sample frame are the members of the National Education Center Association. It's not, say, a TPTA. I think there's a couple different teacher unions here in Texas that are different from that. And so we are left out. And so, but if they're not worried about us, that's fine. So you set your sample frame to the population you're interested in. In this case, they're interested in members of the NEA. So it's all members of the NEA, and we do a sample here to make sure that we get some sort of representation. Number 12, Capital Car Wash sells a membership card for $25 per year that entitles a buyer to a $2 discount on each car wash purchased during the year. The number of times Danica washes her car has a mean of 15 with a standard deviation of 4. Which of the following gives the correct mean and standard deviation of the amount of money Danica would save if she buys a membership card? So first of all, we know that saved is going to be 2 times every time she washes her car, minus the cost of the $25 card, right? So my expected value behaves very well. I'll just stick my expected value in there and I get $5. So we're pretty sure it's either A or B. Now we need to go see if we can figure out the standard deviation. Well, this is a transformation. I'm just taking my value and I'm putting it through an equation. So I'm taking the number of cards and then putting it into the number of times washed, and then putting it in to figure out the amount saved. Okay, so we just modify the equation for standard deviation. This is much faster than doing variance, and we ignore plus or minus by constant. So it's the same equation, but for standard deviation, and cross off any addition or subtraction by constants, plug in your value, and you're done. So it's not so bad when it's a transformation. Just remember to cross off that add, subtract. In a set of 8 boxes, 3 boxes each contain 2 red and 2 green marbles, while the remaining contain 3 red and 2 green. A player randomly picks a box and then randomly picks a marble from that box. She wins if she ends up with a red marble. If she plays 4 times, what is the probability she wins exactly twice? So this is a super mean problem because, first of all, I have to figure out the probability on one attempt. What does she win? And on this one attempt, there are 2 steps. One is picking a box and then probability of a red marble on that particular type of box. So yes, we're bringing our tree diagram in. So first of all, there are 8 boxes, and 3 out of 8 are that first box. I'm calling it box 1, and 5 out of 8 are like box 2. In box 1, 2 out of 4 marbles are red. So we 3/8 and 2/4, and box 2, 3 out of 5 marbles are red, so they're winners, right? So then I say, okay, probability of box 1 and winning is 3/8 times 1/2, basically 2/4, is 3/16, right? And then the probability of winning on box 2 is 5/8 times 3/8, which 3/5, which is 3/8, and I get 0.375. So the probability of winning in general is adding these 2 up, and I get 0.5625. So I'm done with the first part. Now I know that the probability of winning once you play on one attempt is about 56%. But we're going to try 4 times, so n is 4. P is 0.5625. And we want to know the probability we win exactly twice. So you could put this in the Staplet, but let's go ahead and get you guys used to the calculator. So it's going to be binom PDF. Why is it PDF? Because X is exactly 2. Remember, C does the less than or equal all the time. It goes from 0 to the 2, but I'm not interested in 0 wins or 1 win. I want exactly 2 wins. And you plug and chug into your calculator or your Staplet, and you get your probability. Number 14. The following figure is a normal probability plot of the heart rates of 200 male runners after 6 minutes of exercise on a treadmill. What is the shape of the distribution of heart rates? So basically what we're looking at, the z-scores, now you can see there's more data here and less data here, but the z-scores kind of correspond to their position numerically. So if the z-scores kind of match and it's linear like this, then we consider that to be approximately normal. Approximately normal, okay? So that is your answer there. The skew is always a little hard to determine, so it might be easier to make, if I was doing skew on this, if it was skewed, if there was a curve, the curve was going to change depending on which one of these is on the y-axis and which is on the x. Personally, I would figure out the percentiles and see if there's stretches there. So 0, we know, is at the 50th percentile, and then you have the -1. Let's see, that's about, so you could figure out that's about the 34th. You could kind of go in, or actually the -0.67 is the 25th percentile, right? So you could take a look at those and then see how the box is looking, if it's exceptionally one way or another. You can see the values are pretty much going from -3 to +3, and it's a line. This one is fine. Number 15, a basketball player claims to make 47% of her shots from the field. We want to simulate the player taking sets of 10 shots, assuming that her claim is true. To simulate the number of makes in 10-shot attempts, you would perform the simulation as follows. So first of all, we're going to use, we need to model 47 out of 100 outcomes, not incomes, outcomes. And we can do that with just 2 digits because 0, 0 gives us that extra digit and 99 is the high. I need 47 outcomes to be a make. So if I start at 0, 0, I go just up to 46. Then everything else, 47 and 99, are a miss. And it already tells you to go ahead and use 10 random 2-digit numbers. We don't need 47. That would be 47 shots, right? We need 10 shots for simulating. All right, and then last but not least, if a player rolls a 2, 3, or 12, it is called craps. What is the probability of getting craps or an even sum on one roll of dice? So let me go ahead and first figure out the probability of craps. So that's a 2, which is 1 over 36, a 3, which is 2 over 36, or a 12, which is 1 out of 36, which is 4 out of 36. I'm not going to try and simplify or convert to decimals because these are going to add pretty well. You see how everything has a 36. Probability of an even would be a 2, a 4, a 6, a 9, not a 9, 2, 4, 6, 8, 10, and 12. So you can see here we add these all up and we get 18 out of 36. Now you might be tempted to add these too, but wait a second. Craps has a 2 and a 12 in it. So what's the probability we get both of these at the same time? Well, that's for the 2 or the 12. We add it up, we get 2 out of 36. And then, so I could say the probability of even or craps is, I guess I have the wrong order. But anyways, craps is 4 out of 36 plus 18 out of 36. Subtract the overlap, which is 20 out of 36. Now, what you could have also done is you could have said, okay, I'm going to do the evens and then just go figure out which craps one is not even, which is the 3, and add it there. So you could have done a shortcut on this, but I thought we'd practice with our formula. And that is your answer.